With Mrs. Milburn, you learned that if two functions are inverses of each other, when we graph them, they should be reflections across the diagonal line y equals x. So let's graph the two of them and see if they truly are functions across that diagonal line. So f of x is 2x minus 5. Just going to use the good old slope-intercept deal. Y-intercept's negative 5. Rise over the run. I will try to draw a straight line here. Can't promise. That would be our f of x function. And then g of x has a y-intercept of 2.5, and the slope is a half. So up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, 1 over 2, or we could go down 1 over 2, down 1 over 2, and so on. We get the idea. And I'm having trouble drawing a straight line, but these are indeed reflections across the diagonal line y equals x. Although my lines weren't perfectly straight, we could check some points here. On the f of x function, this is the point 0, negative 5. Its reflection over here, if I continue this long enough, for the g of x function, this is the point negative 5, 0. So the x and the y are switched. A similar thing here on the x-intercept. So for the f function, this is 2.5, 0. On the g of x, this is 0, 2.5. So again, they are reflected across the diagonal line. Therefore, yes, these are inverses of each other. The second method requires us to find the inverse of each function. If the inverse on the f function is the same as the g function, and also if the inverse on the g function is the same as the f function, then they are inverses of each other. And we have to figure them both out. So to find f inverse of x, we're going to use that multi-step process that Mrs. Milburn showed us. We're trying to find f inverse. So we're going to replace the f of x with y. And then if you remember, we switched the y and the x. And solve for the new y. So to solve this for y, we're going to have to square both sides. And then to get y totally by itself, and then we can rename this now. This new y value is actually f inverse of x. And I made a mistake right here. You're supposed to add 6 to both sides. Been a long day. So does f inverse come out the same as g of x? Yes, it does. G of x is the inverse on the f of x function. But that's not good enough. We have to check over here. We're going to have to find g inverse. and see if it is going to be the same as the f of x. Same process, going to replace g of x with y. Then we switch the x and the y. And solve for the new y. So we could subtract 6 from both sides. Try to do it right this time. And then we can take the square root of both sides. But we have to remember, and we had to do this when we were doing some of the factoring, solving by the square root method, that when we take the square root of both sides, this could be plus or minus the square root of x minus 6. If it was the positive value, when you squared it, you would get y squared. If it was the negative square root, when we square it, we would get y squared. So this is not the same as f of x. Let's check it out on the graph. Now, I set up tables, but you would know what this graph looks like from its parent graph. And because the 6 is in with the x, it's going to be doing the opposite. So instead of starting at the origin and making this sideways parabola, top half of a parabola, it's going to start at positive 6. It's going to move 6 bases to the right. So we could start there. We put in a 6, we'd have the square root of 0. If we put in a 7, we'd have the square root of 1. If we put in a 10, we have the square root of 4, which would be 2. And I'm kind of going to run out of space here. So we have 6, 0, 7, 1, and 10 is going to be 2. And our graph is going to go off like that. Over here, if we put in a 1 and square it, we get 7. If we put in a 2 and square it, add 6, we get 10. If we put in a 0 and square it and add 6, we get 6. If we put in a negative 1 and square it, add 6, we get 7. If we put in a negative 2, square negative 2, add 6, we get 10. So across 1 and up 7, across 2 and up 10, across 0 and up 6. But you knew all along from that parent function of x squared, if we put a plus 6 on the end, that it would raise the whole parabola up 6 bases. But then over here we also have negative 1 and 7, negative 2 and 10. My graph is not turning out too well because I put a piece of Scotch tape here to hold the paper down. That was not good planning on my part. Shows up a little better now. So this does not pass the horizontal line test. And you learn from Mrs. Milburn that maybe we can restrict the domain. If we want to make this pass the horizontal line test, we can restrict the domain to x is greater than or equal to 0. And if we do that, we will be using only the right half of the parabola here. And that would be a reflection across the diagonal line, y equals x then. This half of the parabola would be an inverse with the original f of x over here. But for the two functions we originally had, they are not inverses of each other. Not unless we restrict this one to say for x greater than or equal to 0.